these conditions and find maybe what a minimum cost would be for a product that I might be making, or maybe what's the maximum profit. So if I wanted to try and sell something, how could I maximize my profit based off of certain restrictions that I might be looking at? So that's called linear programming. We're going to do that tomorrow and Monday. Looking ahead to next week, you have a quiz on the first half of this chapter next Wednesday. So the quiz on Wednesday, I think it's a 30-point quiz. It might be 25 points, but it's on solving systems, graphing algebraically, substitution, and then graphing inequalities. So hopefully it's a fairly straightforward quiz on Wednesday, but it works out that everybody is at an equal opportunity because everybody will be home next Wednesday. It just happened to work that way. It will not always be like that. The last time you took a test, you happen to be home as well. But I know the chapter 3 test is not going to work out where that will be done on a Wednesday. So they will start where sometimes half of you'll be in class and the other half will be at home, and then it'll flip where the other half will be here. That might not be. So kind of just work on that and see how that goes. Tonight's homework is in the book. So it's 8 to 15 all, and those are graphing. And then 34, and then 41 to 47. These are a couple of review problems to try and get some spiraling back in, to review the concepts that we talked about in chapter 1 and chapter 2. So a couple of review problems there, and it's really just a couple, just those odd 41 to 47 odd. So graphing predominantly is the homework tonight. I do have graph paper attached on there if you want to use it. Notability is awesome because you just click the button and graph paper appears. It's wonderful. And it has all the colors that you can use as well. So if you look in chapter 3, section 3, so if you pull out your chapter 3, section 3 notes, we're going to start kind of just by describing what a system of inequalities would be. We talked about a system of equations, but how would that be different if I had a system of inequalities? So, Alyssa, when we had a system of equations, what did it mean for us to have a system? That's what we've been doing. So what did it mean with all the problems we've been doing? What was a system? 2. Yeah, 2. So a system of linear inequalities is going to be 2. I'm going to add the or more part because tomorrow we're going to have more. Today we're going to have 2. Tomorrow we'll have more. We could have 3. We could have 4. I think on Monday you'll have 6 that we'll be graphing. So 2 or more inequalities. And they're graphed on that same coordinate grid. That's what a graph is called, a coordinate plane, a coordinate grid. So we were graphing 2 systems of equations. We were trying to find where they intersect. That was the solution of a system of equations. Now we're graphing a system of inequalities, 2 or more inequalities graphed at the same time. Remember, we're going to have those inequality symbols, the greater than and the less than sign. So a solution of inequalities. A solution of a system is where they intersect, where the 2 lines meet, because it's one ordered pair. What do you think a solution of a system of inequalities is? So think about what an inequality would look like if we were graphing it. What would a solution to the system be for inequalities? Brooke? That's not what you meant to say. I don't know how to explain. When you graph an inequality, Brooke, so let me just draw a line here. Okay, there's my line. What's different from one line that's an equation versus an inequality? What does an inequality have with the graph, besides just the line? Usually has an endpoint. What else does it have? Could have a V. We are going to graph a V. It usually has some kind of shading with it. That's what makes it an inequality when we graph it. So it's not just a line, but we're going to be shading because it's less than the line or above the line, greater than the line. An inequality has shading involved. So that's what makes it an inequality versus an equation. An equation is just the line. An inequality says, well, the answers are going to be above the line, below the line, possibly the line. Just depends what our inequality says. So a solution of two of them, so if I have one drawn up here, and then I draw a second, and maybe this one here, maybe we're shading in this region here. What do you think my solution would be? So inequalities have shading. I now have one line and a second line with shading. What do you think the solution is? Shaded? Yeah, where they're both shaded together. We call that the overlapping region. And it's going to be any point in that overlapping region. So we no longer have one point, and yes, where they intersect could be the answer. But we will have all of this region that's overlapping, and any point in that region is the solution. So not just one, but as long as it's in the region, then it could be an answer for our problem. So that's what makes it an inequality. An inequality we graphed back in chapter 1 on a number line. An inequality has many solutions, not just one, because we're using that greater than or less than symbol. The graph of a system of linear inequalities would just represent all of the solutions to the system. So the graph of a system is really a graph of the solutions of the system. I'll say to the system. So when we say graph of the system, we're really looking at a graph of the solutions. That's what it is. That's what we're looking at. Where are the solutions of our graph? So today we're going to be graphing two lines. As I said, Monday we'll get up to probably 4 or 5. Tomorrow we'll look at 3, maybe 4. And we're going to be shading these lines. And we're going to also be seeing where they intersect. If you're using notability, a great feature, because I would suggest using different colors. One line, one color, the next line, a different color. If you just have pencil and paper, maybe you have a pen and a pencil, or maybe you have some colored pencils to take out, you'll just need 2. So if you have a pen and a pencil, 2 different colored pens, I would say take that out. I know some of you are like, have a nice, like she has that nice pencil pouch over there, probably with lots of colors in there. But you want to have multiple colors to kind of just see that overlapping area. So to graph a system of linear inequalities, we're going to graph each inequality, just like we would the line. We graph each line. It says you may want to use colored pencils or different colors on the Notability app to distinguish the different lines, the different solutions, or shaded regions. And then we will identify the region. So again, it's not just one point, it's now an area of the graph, a region of the graph. That is common to all the graphs of the inequalities. This region is the graph of the system. So again, the graph of the system is that solution region. If you use colored pencils, the graph of the system is the region that has been shaded with every color. Or both colors, depending on how many we have. So that overlapping region where both colors are kind of shaded or meeting together. All right, so we're gonna see if we can graph the first one, which I tried to keep it pretty straightforward. Looking at these, no longer do I have equality, but I have inequality. And just a little review. There are 4 different types of inequality symbols. 2 of them are just less than and greater than. The other pair would be less than or equal to or greater than or equal to. When you have a line that is just less than or just greater than, does anybody remember what you do special when making that line, when connecting your points? Alyssa?
If it doesn't include the line, it would be dotted.
Excellent. If it doesn't include the line, it is a dotted line or a dashed line, however you want to say that. So if it doesn't have the equal to, it doesn't equal the line. That means I can't draw a solid line when I'm connecting my points. If it does have the equal to, then it is a solid line. So we're going to look at that part first. Make sure that when you notice your equation or your inequality, that you're graphing the line correctly. So the first one, we have y is less than 2x plus 1. So you're going to graph the line just like you did for the last section. We're going to go up to 1 and then apply your slope, rise over run. And then when you connect this line, we're connecting it with a dotted line because it says less than. So make sure you connect your line. Mine doesn't look so straight, but it's dotted. Now the next part is the shading part. So how do you know which way to shade? Here's my line, but that's not my solution. It's a shaded area. So how do we know where to shade? Ava, do you know how we decide where to shade?
For symbols less than, right?
Yes.
So it would be less than, so to the right.
Okay, so instead of saying to the right, can you think like above versus below?
Yeah, so
Below. And I know you're saying, yeah, but that line's kind of diagonal. But when we think of something being less than or greater than, I want you to go to a point on that line and think of being above the point or below the point, not left or right. So less than means below the line. So we're shading the area below my line. Yes.
So we're shading where like y is according to the equation and not, because I used to think it was the opposite.
Yes.
Okay.
Yes. So you're shading based off of the y of the equation, the height of that y value, above that y or below that y in the equation. Good question. Yes. This one right here?
Yeah.
Is yours different than mine? Does everybody have -2? You have +2? So up 2 over 1? Okay. Maybe you're trying to pull the second equation in. So if we look at the second inequality, the second inequality says -x minus 3. So going down the -3. And then graphing that, the negative means down 1, right 1. Or it might have to move up 1 and backwards 1. So I'm either moving down and right or up and backwards. That line should be going down because it has a negative slope. This one says less than or equal to. So if it equals the line, we have it being a solid line. So connect it with a solid line. And then again, less than means below. So this is still less than, it's just less than or equal to. So go to a point on that line, and this is where you have to think above versus below the point on the line. So I'm going below the point on the line. So when I shade, I either shade up or down. I don't shade left or right unless I have an absolutely straight vertical line. Otherwise, I'm thinking above the point or below the point on my line. And then the last part, it says graph the system of inequalities, use different shades for each half. Identify the region that is common to both. And that would be the place that you're going to darken in. Make sure that when somebody is looking at it quickly, if I was walking by or Ms. Park was walking by, she would be able to identify the region. We shouldn't have to guess. So if I see all this scribbly stuff and not an actual bolded area, then that's not really the solution. Question?
I'm a little confused on how you determine what side to shade in.
So less than is below. So I go to any point on the line. Let me get the right color here. Here's my point. I'm going below that point. Never left or right. So here, less than means below a point. Here's another point below it. So I would go to every point on that line and make sure I'm going below the point on the line. So if I had greater than, then I would have to go above. But like, don't think left or right, because less than is above versus below. Greater than up, less than down. So either above or below the line. And then we have to shape in the actual solution, which is the area where both of my colors are down here intersecting. Again, make sure you darken that region. It should be obvious. I shouldn't have to like assume that you know what you're doing, where the solution is, or you shouldn't be assuming that I know what your solution is. It should be an obvious solution. So obviously, I have a couple more that we're going to do. We're going to throw in an absolute value graph as well to make it a little more interesting. Are there questions on this problem?
So how do you write the answer? Like,
You actually don't write the solution. That's a good question. So the way you write the answer is by darkening the region. If you wouldn't darken the region, then you wouldn't be writing the answer. But we wouldn't write a physical point unless it said name 3 solutions to the system. And then I could say any point. I could pick any point in here. Mine's so dark now I can't even see any of the points. But I could pick any point in this darkened region and it's a solution. But there's just not one answer. So I don't want to write where they cross. But the whole answer part is darkening that region. That's your answer. So if you don't darken it, then you're not actually like writing the solution. That's a good way to think about it. Other questions? All right, let's look at another one. So again, it says to graph the system. We have 2 inequalities. The first one, y is by itself. The second one, it's not. So obviously, you'd have to get it in y equals form, or y by itself, to be able to know what the slope and the y-intercept is. So see if you can try and graph the first inequality. Y is already by itself. And if you need to remind yourself less than or equal to means shade below, greater than or equal to means shade above. So you cannot think left versus right. It's above versus below. My greater than, my y values are above the line, or my y values below the line. So that's what the y is. So we want the y values above the line or the y values below the line. And feel free to use a highlighter pen that might help shade it better. This slope down 3 over 4. Don't forget to look at your inequality symbol so that you know, is it a solid line or is it a dashed line? So Julia, what was the second inequality that you found?
I got y is greater than negative 2 or x plus 4.
Nice. All right, so I have my first line graphed up here, but I didn't shade it. So if this is my line and I go to a point on the line, it says less than for the first inequality. So again, go to a point, less than means below. So I'm going below every point on the line because it says my y value should be less than the line. Y is less than my equation or my expression negative 3x plus 1. When you go to graph the second, this time we're going up 4. Brooke, what kind of line are we making here since it says y is greater than? 1, 2, 3, 4. Yep, I think I counted up from the other point. Thanks. Here we go. So she said it would be a dashed line. And then how are we shading if it says greater than? Above. So any point on this line and we're going above the line. So the solution is supposed to be the overlapping region of the system. What is the solution? What area do I darken? Jaden?
No solution?
Yeah, why isn't there any solution?
Because there's no point where they overlap.
Excellent. There is no solution because there is no point, no region where the lines are overlapping or the shaded areas are overlapping. So in this case, you do write a solution. You write no solution. If my inequality symbols were flipped, my area could also be maybe just in between the lines. That could also be the solution. So it just depends on where the symbols are going. But if they're not overlapping, there cannot be a solution. So the overlapping region is the solution to the system. Questions? We're on section 3 in your packet. So I believe there are 2 other graphs that are underneath here. And I throw in this nice absolute value bars around the graph to get us to remember about that. Again, math is a spiraling subject. So it means once you use it, it comes back and you get to see it again. So this one for letter A, the first one says y and just y is less than or equal to 3. How do you graph y is less than or equal to 3? What kind of line is that? Lacey, do you know what kind of line y is less than or equal to 3 would be?
Would that be a vertical line or horizontal?
One or the other, huh? Well, what are they telling me first? What's my y value? Y is less than or equal to 3. So I'm going to go to where y is 3. I'm going to start off with that. So here's the y. I'm going to go up to where it is 3. I'm going to do the equal part first. There's equals. So this is saying y is 3. So do you think I make a vertical line through that point? Would that be all the values when y is 3? Or would I make a horizontal line through that point? So I want every y value to be 3. It is horizontal. Remember, horizontal lines have a slope of 0. Think of the horizon. The horizon is a horizontal line. That would be my y equals horizontal. And it says less than or equal to, so I can make a solid line. So that's my y equals 3 line. The less than part is the shading part. So when you have y, it's horizontal. And now shading, I'm going less than the line. So this one's nice because it's horizontal. It's obvious that it's less than or greater than. It's obvious it's below or above. So below is less than. You're less than something, you're underneath it. You're smaller than it, you're below it. All right, that's my first graph. The second one might be a little trickier. Gabby Soul, do you remember what kind of graph you would get from absolute values being around? The x plus 4, what would the shape of the graph look like? So what is the shape of our graph? I have these absolute value bars. That is a V. So absolute value makes a V. So this graph has to be a V. So absolute value is going to be a V graph. We have to remember where to move this graph. Where is its vertex? And remember, that's this part inside. The general equation is x minus, and then because this is a plus 4 is really minus a negative 4. So absolute value has that vertex that we talked about last chapter. Jaden, where would our vertex be? Yeah, at negative 4, 0. It's 0 because there's only a number with x. There's not a second number being added or subtracted. So we're going to move over to negative 4, 0. 1, 2, 3, 4. This graph is supposed to be a V. The number in front is the slope. Really, there's a 1 there. So remember, that slope tells me on the right side, I'm going up 1 over 1. On the left side, I'm also going up 1, but I have to go backwards 1 because the one side is positive, the other side is a negative slope. So up 1, backwards 1. So again, you should have a slope of negative 1 on the left, a slope of positive 1 on the right. If you can just think, I need to move up and then both directions, up, left and right, up, left and right, up, left and right each time. That then gets that slope being positive and negative. So I need to connect this line. Gabby Snyder, are we connecting our not line, but our graph here that's going to be a V with a solid or a dashed line? Dashed, yeah. So dashed because it says greater than. And then, Gabby, it says greater than. So when it's greater than, would we shade above this V or below the V? Yeah, we're going to shade above. So I'm going to go to a point because Y is greater than. So I'm going to a point in my V. I'm going to start with the vertex. I'm going above that point. Another point, greater than is above. Above the point. Over here, above the point. So always think, go to a point on the line, go above that point, that's greater than. And then don't forget to shade your final solution. That's how we're writing our final answer. We need to shade it, darken it in, make it obvious if Miss Carp is walking by and peeking over your shoulder. She should see that you know where the solution is because it's darkened. We're not writing a single ordered pair. We're not writing multiple ordered pairs because it's all of them inside that area. Questions? So if you haven't, I'd like you to see if you can graph B. Try and use the same process that we just did. So this time you have absolute value. There's a 1/2 in front. That 1/2 is the slope. Think about how the V is moving. The second equation, be careful because it says X is greater than or equal to -2, not Y. So A gave us Y, part B is giving us X. Just be careful with that. So I ended up graphing the second inequality first, and that inequality told me X was greater than or equal to -2. So the first thing I did, I went to where X was 2, and I put a point on the X-axis at -2. This time, X is a vertical line. So X vertical, Y horizontal. Now, when you're shading in this case, this is the only time where you get to think left versus right. And it says X is bigger than -2. So the numbers bigger than 2 on the X-axis are the positive X values. So that's why I shaded to the right. But it's the only time you get to think shade right versus left, because I have a vertical line cutting my graph into a left side and a right side. So we graph to the right because X is bigger than -2. So all of these X values being bigger than -2, positive X values. The second graph, this is our absolute value. Ava M, where is the vertex of this absolute value graph going to be?
-2, 0.
Excellent, -2, 0. Remember, this is really X minus a -2. So it's moving to -2, 0, which happens to be a point that I have from my other line. And then Ava, what's the slope of this?
1/2.
Yeah, 1/2. So up 1, right 2. Going back, I'm going to do the same thing, but I'm going to go left 2 this time. Up 1, left 2. And then it says less than or equal to, so equal to again is solid. All right, here's the tricky part. How do you shade? So Ava, if it says less than, and I go to any point on my line, how am I going to shade from that point on my line?
Below it.
Yeah, below it. So less than is below. Let me see if I can get my highlight back. So less than is below. So again, below any point on my line. My final area is where the 2 intersect or overlap. And that's this part right here. So underneath this diagonal line, to the right of that vertical line, That's where I got green. My two colors overlap to make a green. Any questions? So we are going to see if we can set up one more problem, and it's the application problem. As I said, those word problems, every day we'll look at a word problem. So there is one more problem. We're gonna see if we can set this up. I don't think we'll have time to graph it, but we'll at least set it up.
You want to do the fill in the blank in the bottom there?
Oh, I don't know. Is there a fill in the blank?
Yeah.
I guess that is common to both.
Oh, that's what I thought.
Yeah, sorry, I guess that was probably at the bottom of my screen and I just didn't see it there. So that bottom part, do I have it on mine? Oh, I didn't even copy it on mine. So you're shading the area that's common to both. So the last question, we're gonna just set this up. You're selling pizzas to raise money for a field trip. Cheese pizzas cost $8. Pepperoni pizzas cost $9. You need to sell at least 2 of each pizza type. And you want to sell at least $150 worth of pizzas. So cheese versus pepperoni. So essentially, you're selling a cheese pizza to your neighbors for $8. You're selling pepperoni pizzas to your neighbors for $9. That's what you're selling them for. You want to raise $150 by selling the pizzas. So the first thing we need to do is remind us, which I actually wrote in here, X is the number of cheese pizzas. I think somebody asked on the homework yesterday, how do you know which is which? You get to decide, but you have to decide at the start. I'm going to make X be my cheese. I'm going to make Y be the pepperoni. If it's not stated for you, you pick. So it's up to you. I always make X be the first thing they talk about, Y be the second thing they talk about in the problem. So that's already given. If cheese pizzas are $8, I'm selling them for $8. Pepperoni pizzas are $9. I want to sell at least $150 worth of pizza. How could I write an inequality for that? Brooke? Perfect, yeah. At least means that's my minimum amount. I want to be bigger than that. That's where we use the greater than or equal to sign. So at least, minimum 150. But really, we want to get more than that. We want to be greater than that amount. There's another piece of information in here that says I have to sell at least two of each pizza type. How would you write that as an inequality? I have these 2 different pizzas. I have to sell at least 2 of each of them. I see.
Did you say X plus Y is greater than or equal to 2?
You are so close.
Not 4.
No, you're so close with 2. But think of them separately, because separately I need to make sure I sell 2 of this kind and separately 2 of this kind. Brooke?
Y is greater than or equal to 2, and 2 is, oh, I was just gonna put it in 1, X is greater than.
So of each type of pizza, so that means of the cheese pizza, I need to sell more than 2. And of the pepperoni pizza, I need to sell more than 2. So not combined together, but of each individual type. So I would just write them as separate inequalities. So homework again tonight, 8 to 15, all of 8 to 15. You're graphing 2 inequalities. Some of them are absolute value. There is a 1 word problem, and that was question 42, I think. And then there are a few, not 42,